example 6, this will give us a chance to practice our pattern recognition. Okay, and for each of these, if we think about the derivative of cosine of 2x as being negative 2 sine of 2x, this will help us solve each of these problems. Okay, so the first one, I don't like that 5 in there. I'm going to pull it right out. We have the integral of sine of 2x times e to the cosine of 2x dx. So notice we have that cosine of 2x that I was talking about. Okay, and we almost have this. It's just we're off by that negative 2. So I'm not going to show this step every time, but I could put a negative 2 there. If I do that, I have to correct it by putting the negative 1/2 on the outside. Alright, so I'm not going to show that correction every time, like I said, but I am going to pull it out right now. So I have that 5. I have the correction of the negative 1/2. Now, I just have to take the antiderivative of e to the cosine of 2x. Okay, and I picked this function because this is like the bulkier function. This one, it's a little bit more complicated. And plus, I told you we're using pattern recognition of the derivative of cosine. All right, so the antiderivative of e to the cosine of 2x times the other part would be e to the cosine of 2x. All right, plus c. So there we go, negative 5/2 e to the cosine of 2x plus c. If you take the derivative of that, you get negative 5/2 times e to the cosine of 2x times the derivative of the inside. So that's where that negative 2 sine of 2x comes in. That'll cancel with our negative 1/2 we have, and we'll be back to that original function. All right, next one. I don't like the way this is written. I'm going to rewrite it. I'm going to pull that constant out. I have my sine of 2x times, and this I have cosine of 2x to the 2/3 power. Alright, so this is similar to what we had last time. I have my 7, that's my rider constant. I am again missing that negative 2, so I need to correct for it by multiplying by negative 1/2. Alright, now I just need to do the antiderivative of cosine of 2x to the 2/3 power. Alright, so I add 1 to the power, get 5/3, divide by that new power, and then I just fill that part in, cosine of 2x plus c. There you go, that's it. Now if you want, you could plug these all in and simplify it. Cosine, and you could rewrite this if you'd like as a radical. I don't really want to. There you go. Alright, or you write negative 2.1. Now for any of these, you could also use U-substitution. Right now I'm just getting you to practice that idea of pattern recognition. Alright, I see a constant. I don't want it there. I'm going to pull it out. I notice again that I have a cosine of 2x, which is what I told you I'd have. And the derivative is very close, right? We're just off by a little bit. So this is the one that I'd like you to do in your whisk. So go ahead and write the answer in your whisk for part C of example 6. Okay, moving on. We have part D here. This is getting a little more involved now. Look at this bulky function we have. Alright, no constants to worry about, but we do need to correct for the derivative here. The derivative of cosine of 2x is negative 2 sine of 2x. So we have to correct for that negative 2 by putting a negative 1/2. Now, our main function here is sine of this. Alright, so we have, what's the antiderivative of sine? That would be negative cosine of this, cosine of 2x plus c. Okay, if you feel like rewriting it, you could do it this way, cosine of 2x. There we go, plus c. Not too bad. Alright, whoa, look at this one. This one's a little bit crazy here. First things first, I'm going to pull out my constants. Alright, and then sine of 2x Let's see, I'll write it with a power, cosine squared x minus sine squared x. That looks kind of familiar. Wonder if this has anything to do with those trig identities that we love so much. It does, okay? So, if you recognize this as a trig identity, this is equal to cosine of 2x. Right? That is a double angle identity there. So I'm going to go ahead and replace that now. So I'll have 2/3, and I don't like that being on the bottom, so I'm going to pull it up. Sine of 2x times, now again I have cosine of 2x, and this will be the negative 1/5 power. Alright, so we have our rider, we have our corrector again. Okay, now it's just time to do the opposite of the power rule. So add 1 to the power, we get 4/5. Divide by that new power, 5/4. Write this part in, what function we were talking about, and put your plus c. And if you feel like combining this, let's see, I think it would be negative 5/12 cosine of 2x to the 4/5 power. And again, you could write it as cosine of 2x to the 4th power, and then the 5th root of that, but I'm not going to. Alright, and there you go. So we have one more here. There's a couple ways to do this one. It's kind of a neat problem. Alright, let's see, 11, I'm going to pull that out. Sine of 2x times cosine of 2x. Man, that looks like another identity we have. But I'm not going to worry about that right now. So I just have this function here to the 1st power, and I have the derivative. Okay, almost. I need to correct it by putting that negative 1/2 there. Now it's just the power rule. Okay, add 1 to the power, so we have this function. Add 1 to the power, divide by the new power, and don't forget your plus c. So we get negative 11/4 cosine of 2x squared plus c. That's it. Alright, still not too bad. Right. Evaluate this one 2 different ways. Show that the antiderivatives are equivalent, but only for a constant. Alright, so you can use U-substitution or pattern recognition. Alright, so I'm going to notice here, I know that secant squared of x is the derivative of tangent of x. So as that pattern here, I'm just going to write, so I'll show that real quick. I know that the derivative of tangent of x is secant squared of x. Okay, so because I recognize that, this is like the chain rule in reverse. So now this is my big function I'm worried about. This is taken care of. It's all packaged in that derivative part. Okay, so the antiderivative of tangent of x to the 1st power is going to be add 1 to the power, divide by the new power. Okay, and don't forget your plus c. So I have 1/2 tangent squared of x plus c. Alright, now another way of doing that is writing it a little bit differently maybe. Alright, so I'll have secant of x times secant of x tangent of x. Alright, here, if you recognize that the derivative of secant of x, and again, this isn't something you write, this is something you get with practice, okay, is secant x tangent x. Well, then this is the function I'm trying to take the antiderivative of, and this is taken care of by the chain rule. All right, so the integral of secant of x to the 1 would be secant of x, add 1 to the power, divide by the new power. Now it says that these are the same if only off by a constant. All right, and this is where one of those wonderful trig identities that I'm sure you remember, 1 plus tangent squared of x equals secant squared of x. Alright, so I'll show you that it's only off by a constant. Instead of writing secant squared, I'm going to write 1 plus tangent squared of x. Alright, and then I'll distribute that out. This almost looks the same, right? Except for this 1/2 here, but that's just a constant. So you can think about it as like c plus 1/2. But c plus 1/2, that's also a constant. So it's exactly the same, okay? But it's only off by some constant. There you go. So it's, again, it's kind of a neat problem. Example 8, I think I'll finish with 8 or 9. I'm not sure yet. Let's take a look. This is a pretty neat problem. There's a lot. Wow, look at that function, right? But we see that this is maybe a more complicated function. So if I think in my brain, all right, wait, what's the derivative of 5 to the x cubed plus 7? All right, well, you repeat it times the ln of 5 times the derivative of the inside. So that's pretty close to what we have. We're only off by constant factors. So this is something we're going to be able to do. All right, so if I pull out that 4, I don't want it yet. X squared times 5x cubed plus 7, or 5 to the x cubed plus 7, times, now this is my main part of the function, secant of 5 to the x cubed plus 7, and secant, this whole part is squared. So again, this is my main function. This is taken care of by the derivative. However, I can't forget about adjusting for those constants. All right, and some of you probably want to see it, so I'm going to write this in. If I had this ln of 5 here, man, that would be great because then I can take care of that. And if I had a 3, I'll just put it there, that would be great, but I don't. So I have to correct for it. All right, so I'm going to bring down that 4, that rider function. I'm going to correct for the ln of 5. I'm going to correct for that 3. Now, all of this is taken care of. I just have to worry about the secant squared. So, using the power rule, or the opposite of the power rule, I guess. Add 1 to the power, divide by the new power. Don't forget your plus c. Oh, whoops. That's not it. That's not it. That's not it, because that wouldn't be, the derivative of secant cubed is going to be a little bit messier. All right, let me fix that. That's what a lot of you will probably do, all right? But the derivative, the antiderivative of secant squared is actually tangent, okay, of 5x cubed plus 7. And then plus 3. There we go. Don't want to forget that. So if you take the derivative of tangent, you get secant squared. That's what I have here. And if you want, you can combine this together. Oh, that one, I should have erased this. That shouldn't be there. All right. So we have this function here. And again, if you wanted to, you could combine those, but I don't see a point. All right. That's good enough for our answer. Now, this one here, we have a lot going on, right? And this is what you're thinking. I'm going to write it small because it's what you're thinking. You have, oh, that's not small. You're thinking, all right, which of these looks like the messiest function I have? Probably this, e cosine 5x cubed. So what would be the derivative of that? All right, it would be e to the cosine 5x cubed times the derivative of the inside. So that would be derivative of cosine is negative sine 5x cubed times the derivative of the inside of that, which would be 15x squared. There we go. So we're only off by a constant again. I'm going to pull out that constant. We have x squared times sine 5x cubed times e to the cosine of 5x cubed dx. So if I make my function this part, this is taken care of by the derivative, the inverse of the chain rule here, and I just need to correct for the constants. I have my rider. I need to correct for that negative, okay, that was up here, and I also need to correct for this 15. So I have 1 over 15. Antiderivative of e to a power is e to that power plus c. All right, so we have this beautiful function here as our antiderivative. And again, you guys have those awesome calculators. You can check any of these, type them in, and see if you get that antiderivative. Okay, you could type in this part and see if you get that. Or your calculator is smart enough, you could type this in, see if you get this. All right, you can do that. Now, I would like you to do this so we could talk about it in class. This will be a great intro to what we're going to do next time. All right, so I'd like you to figure these out. These are really quick. You should already know them. All right, and don't forget your plus C.